In this video lecture, we're going to talk about the while loop. We'll look at how this is implemented in visual logic. We'll talk about some terms related to while loops, and then we'll look at some applications of a while loop and discuss how those are put together and the logic behind them. So the first thing we want to do, if we want to explore using the while loop, is add the while block to our program in visual logic. And if I zoom down, I can select a while loop directly from the pull-down menu. Now, one of the things you'll note is that this is going to show us how logic is going to flow, or how our program is going to flow based upon the logic that we have inside of the while block. So the while loop, its goal is, normally, with a while loop, we want the thing to loop until it's done. And the idea of what means done is pretty undefined. We're not sure if we're going to loop 1 time or 100 times. It's just going to be, we're going to loop until a certain condition is met. So, continue to serve customers until there's no more customers. We don't have a defined number of customers. We just know that we want to keep serving them until we're done. And one of the things you'll note here is that if the expression in this block is true, we're going to follow the true path and note that this actually comes back up to the condition. And this indicates the fact that we'll be able to put any number or type of programming blocks inside of this looping area over here on the right, and they will continually be executed, and each time after they're executed, this expression will become checked. Anytime this expression becomes false, we'll exit the loop structure and continue with our program. So essentially, as long as this expression is true, we're kind of stuck in the loop. We're going to be going ahead and we're going to be executing some items. So before we write the expression, I'm going to put a little output in here, and I'm going to just say looping. Oops, I got caps lock on. And what will happen here is, as long as this expression up here is true, and we'll write that in a second, we will continue to basically print out the word looping. So what I'm going to do is, I am going to go ahead and I'm going to put in a statement or a conditional expression that's always true. So a statement such as 2 is greater than 1. And this is a statement that will always be true. There's, hopefully no way that 2 can ever be not greater than 1. And so if we print this, run this and look at what's printed, you'll note that this expression is evaluated. 2 is greater than 1, so it comes down here and it prints out looping. And notice it just keeps going. And this will go on infinitely. And this is an example of an infinite loop. Why? Because this condition is always true. There are some instances where we do want to have an infinite loop, and that's okay. But this is a common error that you'll get. You may not want an infinite loop, and you'll end up in one. One of the things I do want to point out, and I'm going to stop this by hitting the terminate button, is that up to this point we have been utilizing this pop-up menu kind of approach to working with our output. But I'm going to switch in this case to using console output. And one of the things that you'll note is this little character appeared at the end. This character we're going to use as an end-of-line character, and we'll see how that's applied as we go forward. But what I want to do is compare the difference between having dialog box output and console output. So you'll note that the output block actually changes to demonstrate that we have this end-of-line character here. And then also you'll note that this rectangle appears to indicate that this output block is now using the console. And if I run it, what you'll see is that this continually just keeps outputting the string looping. And a couple things to note is that it's taking up my entire screen, so it's printing left to right and then wrapping back around. Notice it flashing at the end, and that is actually this entire screen, just kind of updating over and over and over again. And so I'm going to stop it. So that's a good example of an infinite loop. One thing to note is, what is this little end-of-line character? Well, in visual logic, when the end-of-line character is right after the string, it pretty much doesn't do anything. But if I put it on its own line and then rerun this, what you'll notice, instead of everything flowing left to right across the screen, now everything is in a straight line. So let's talk about how we can get a little more control over this loop. Instead of having the word looping print out an infinite number of times, what we'd like to do is get this loop set up so that it only executes 10 times. And you'll note that I'm going to print out the word looping, one word on a line, and so we'll look at how we can do this. We want to replace this conditional that is always going to be true with something that will eventually become false. So what I'm going to do is I'm going to create a variable. And the technical term for this variable is going to be a loop control variable. And so for this specific case, I'm going to actually call it LCV for loop control variable. and I'm going to set it to 1. And essentially what we want to do is use this loop to keep track of how many times, use this variable to keep track of how many times the loop has executed. So we want the loop to execute 10 times. We're essentially going to count to 10, and once the loop control value is greater than 10, we're going to stop looping. So let's take this loop control variable now and utilize it in our condition. And so I'm going to set this. We want to loop while the condition is such. We want to loop that loop control value, LCV, is less than or equal to 10. So if I start at 1 and I just go increment by 1, when we get to 10, we want to stop. And you'll notice for now we're going to just deal with pretests. And how is this going to work? Well, loop control value is going to be set to 1. The next thing that will happen will say, is 1 less than or equal to 10? Yes, 1 is less than or equal to 10. That's true. Go to the right, print out the word looping, come back up, and check the condition. Loop control value is still 1. 1 is less than 10. True. Let's run this. And you'll notice I've got another infinite loop. You can even see that this is flashing, and then that the slider bar on the right-hand side is scrolling down as this infinitely prints. Well, that's not what we want. We only want 10 loops. So we tell the loop where to start. We say start at 1. We then tell the loop what condition it should continue to loop under. So while we say, while you're less than 10. But the problem is we're never taking this loop control value and moving it towards this, changing it so that this condition can become false. So what we want to do is every time we come through this loop, we need to increment our loop control value by 1 because we want to count by 1 from 1 to 10. And so what I need to do is inside of my loop, after I print my statement, I need to go ahead and I need to take my loop control variable, LCV, and I'm going to add 1 to it. I'm going to take the current value of LCV, and I'm going to add 1. And the reason why this works is because assignment is right to left associative, in the sense that take the current value of LCV, whatever's stored in there, the first time through it'll be 1, add 1 to it, that gives us 2, and then overwrite the old value with the new value, which is 2. So everything on the right happens first, and then we get the assignment to the variable on the left. And what will happen is the next time through, LCV will be 2. 2 is less than or equal to 10. Awesome. Print out looping. Take 2, add 1 to it, we get 3. Store 3 back into the LCV variable. 3 is less than or equal to 10. And this process will continue on. So now let's run this and see if we get the expected results. And after pressing play a couple times, you'll note that my word looping has been printed the correct number of times. We can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 instances of the word looping being printed. So that's really helpful, and it gives us exactly what we want. So note that if we don't tell the loop how to basically get from the starting condition to the ending condition, it goes on infinitely. One other thing that we could do, if we wanted to, is we could then utilize this loop control value in our output to see how many items have been printed. So through concatenation, we could print the current value of LCV, and then we'll concatenate it with a dot and a period, so that this will say 1 looping, 2 looping, and so on. And let's try to run this again. And now what you'll note is we end up getting the loop control value printed out with each one of our loop iterations. So in this example, we've set up exactly how many times we want this loop to execute. But oftentimes with a while loop, we don't know where the loop's going to end. It might run 10 times, it might run 50 times. And so what we want to do is think about a process for this. So there's a term in the book called a sentinel value. And essentially, instead of having a loop control value, what we're going to do is we're going to take our loop, and our loop is going to run until a certain value is achieved. So in our specific case, what we want to do is a sentinel value is usually a value that is entered by the user or read from an external file. So what we're going to do is we're going to go ahead and we're going to read in some input from the user. And so what I'm going to do is I'm going to go ahead and I'm going to prompt the user for some input. And I'm going to name this variable input. And the user will enter a value. And what we're basically going to do then is say, look, if input does not equal 9999. Now, why am I using all nines there? It's kind of a tradition in programming to use all nines to terminate a program, but at the same time, it's kind of an odd number that for my specific example, we'll assume that if anyone enters those 4 nines in a row, that's our Sentinel value. This is the flag. It says, hey, if you see this number, stop executing. What happens if someone actually needs to enter the number 9,999 for the program? Well, you've chosen a bad Sentinel, so you got to choose a better Sentinel. So in this specific case, we're going to use 999 as our Sentinel. And I'm going to get rid of our output block. And, well, you know what? Let's keep it, and then we'll print you entered, and we'll put input on there. All right, and what I'm going to do is concatenate that together with the value input, and then we'll put that on its own line. And I'm going to leave this set to the console. And one of the things you'll note that I didn't do above is I'm going to come back up to my input, and I'm going to change my input from dialog box to console as well. And I'm going to put enter a value or 9999 to stop. And I'll hit OK. And I'm pretty much at a point where I can run this. And note that now, just like I was using the console for output, I'm going to use the console for input. So let's see what this looks like when we run it, because it might be a little different than what we're used to. Instead of having the pop-up windows, we're going to have the console. So this starts to run. And notice now my input, it says enter a value or 9999 to stop. And so I'm going to go ahead and enter the number 2. And you'll notice, this continually prints out you entered 2. And first of all, one of the things you'll notice is that I didn't put a space in here, which is really annoying. And I'm back at having an infinite loop. Well, notice there's only an output in here. I don't have any input inside my loop either. So there's no way, right, for me to get to this Sentinel value. Just like before, I needed to increment my loop control value to make sure that I could achieve or my while condition could at some point become false. Right now in my loop, there is no way for this condition to become false because once the user enters an input, there's no other chance to do it again. So there is no way that this, this condition can become false. So let's see how we can fix that. And one of the things we can do is we can take this input block and we're going to copy it and paste it inside of this while loop block. And I will zoom out so we can get everything on one screen here. And so now we're going to have a way to get to a false condition here because we're going to read in a value, check that value, output the value, and then read in another value. And we're going to end up in this loop where we're constantly entering a value. And for some reason, my visual logic occasionally doesn't work. So if we enter a value or 9999 to stop, I'm going to enter 2 again. Notice it says I entered 2. I forgot the space. And now it stops and immediately asks me to enter another value. Why? Because the first print statement came from this input. This was true. I did not enter 9999, so it went to the right, printed that output out, now asks me for another input. And now I'm going to do this again. I'll enter 5, 5. You know, notice I can keep going. But as soon as I enter 9999, what's going to happen is this will be false. Input equals 999. It does not equal 9999. Right? I'm using a not operator, so the logic gets a little weird to talk about. But as soon as I enter 999, this will evaluate to false, and my program will exit. And one of the things you'll note in my program is you can't tell that my program is over. So I'm going to actually go ahead and put an output in here that says done. And that way it'll be a little bit easier to see this as it's running. And so now if I run this again, I'll enter 2. And then I'll immediately enter 9999, and you'll note that it prints done. Notice I accidentally left that output as a pop-up box, so you can have a combination of console and output or pop-up box output. Probably not recommended, right? Like when those situations happen, you do really want to go in here and change that to console output. So now we can run it again, and we'll see everything in the console. So unexpected error, but definitely a good error to demonstrate, because we want to make sure that all of our input and output happen in the same spot. So anytime I enter this Sentinel value, this value that means stop doing what you're doing, we end. One of the things that's interesting to note is anytime you copy and paste code, that's usually a good sign that you're probably able to optimize your program. So notice here, I have input, and then I have the same code down here. This is duplicate code. it would be really interesting for us to not have to set this up, right? So that this idea that why do I need to have these two items happening at the same time? So one of the things you can do with a while loop is, if you note this, is I can change from a pre-test to a post-test. And what that means is you'll note that the whole shape of my program change. So instead of checking the condition before we enter the value, what happens is we can go ahead and we can basically put the check of the condition at the end. And so this has moved this to the end. So what it would allow me to do is delete this input and move this up here. And you'll note that now when I run this, I only have one input statement. There may be a little bit of an error here, and I'm going to kind of leave that in the lecture, but this is like a good thing to start thinking about, is if I hit enter, it says enter a value of 9999 to stop. And now if I enter 2, it says I entered 2, 3, and then when I stop, I can enter 4 nines. Notice though, this time around, it actually printed out my Sentinel value. So while I was able to simplify my code by only having one input statement and moving my conditional to a post test, what happened was I now have this situation where even though I had two input statements before and I've been able to simplify to one, I run into this situation where now by changing these things around, that I have to figure out, well, okay, how do I not print out 9999 or the Sentinel? Or am I okay with that? So note that while we can use a post-conditional check to help simplify this specific situation, it may also lead to some other issues that we want. We might need to put an if statement in here and say, well, if it was the Sentinel, don't print that. But then, are you saving anything? Who knows? So these are types of considerations you should start to think about when you're writing programs. And I'm kind of going to leave this a little vague and not talk about it. I just want to point it out as one of the things that happens as you start to play around with the different ways that you can combine this syntax to solve problems. Let's talk about counting how many times the loop executes. I'm going to go back to the previous example of the program where I had two input statements just to kind of keep parity with what we had earlier. So the first time this runs, what we want to do is, we don't know how many times the user is going to let this loop execute, so we need to count it. The only way to do that is for us to set up a variable to count it. So there is such thing, or a fancy name for the variable that counts how many times this loop executes, is going to be called a counter. So I'm going to set up a variable, I'm going to name it counter, and I'm going to set its default value to 0. And I'm going to use this variable to count how many times this loop executes. And so every time this loop gets executed, I'm going to increment the value by 1. And so I'm going to use an assignment statement in here to do so. So just like we've seen in a previous example, I'm going to, in the loop control value, I'm going to take my counter value and I'm going to add 1 to it. And so it'll start at 0. The first time through, 0 gets added to 1. It becomes 1 and saves itself back over the old value. So this idea again that the expression on the right occurs first, and then it's saved back into the variable on the left. And then what I want to do is, we can see at the end, and I'm going to get rid of this output because we don't really care what the user entered. And instead of done, we'll say, loop executed counter times. And now let's run this, and we'll make sure that we don't necessarily, let's do a couple things first. First of all, what if I enter the Sentinel right off the bat? 9999. Uh-oh. And, this is a great example of me getting in an error. Did everybody catch it previously? It's pretty easy to do. I left off the concatenation operator right here. So again, it's good to see that error because I'm sure it's a common error that you'll be getting as you code. And you'll note that it's easily fixable. And it's easily, everybody makes mistakes when they code. It's part of this class is realizing that, and there's nothing wrong with making mistakes. So let's start again. I'm going to enter 999 right away. And what you'll notice, it prints out, hey, the loop executed 0 times. Why? Well, I entered 9999, counter got set to 0. This was immediately false, so it jumped down to here. So counter was 0, never got incremented, stayed 0, and that was printed out properly. So let's run this, and I'm going to enter the number 2 like I did before, and then immediately enter 9999, and you'll note that the loop executed one time. Why? Because it was set to 0. 2 does not equal 9999, so it went to the right. 0 plus 1 is 1. Save it back into counter. Read in the next value. It was immediately 9999, so it exited, and it was false. So that's a pretty interesting way of counting how many times the loop executes. It's very straightforward, just like you would maybe use a piece of paper or your fingers to count how many times an action happens. We use a variable and increment it by 1 to count how many times a loop executes. Previously, we looked at this idea of how we could minimize the number of input statements we have using pre or post test. But let's look at another solution to this, and we'll also use this as an opportunity to look at the exit statement and the idea of accumulating values within a loop. So if you'll note right now, instead of having a condition up here, I've actually typed the word true in. And true is a Boolean data type value. They can either be true or false. And in our programming environment, true is spelled with a capital T. And essentially, instead of having a condition that evaluates to true or false, I can just hard code true. And what I end up here with is an infinite loop that is printing out lots of dots. And you'll note that there it goes. So we get this kind of neat pattern printing out on the screen infinitely. But what's interesting about this is if I want this loop to stop executing, let's say I can utilize a specific construct called an exit loop construct. And so what this will do is whenever the program hits this exit loop construct, it'll immediately jump out of the loop. Instead of an infinite number of dots being printed, I only have 1 dot printed. Because this statement is true, it comes down and prints out a dot, and then immediately hits exit loop and jumps to the outside of my loop. In other words, it doesn't jump to the end of my program, it jumps to the false branch of my loop statement. And so one of the things that we could do is utilize this to our advantage in that same situation where we had the user's input. So instead of using a Sentinel, we could rewrite this problem using an infinite loop and an exit loop program. I mean, we're still going to have a Sentinel value in here, but the Sentinel value itself will not be in our loop condition. So let's go ahead and set this up. So I'm going to add an input in here, and we'll call this value input as we did before, and we'll put the prompt, enter a number, 9999 to quit, and I put a little colon in there. And then what we're going to say is, in this specific case, we'll continue to read values in. We'll get rid of the input statement so that this is a little more compact. But I'm going to put an if statement in here. And what I'm going to say is, if input equals 9999, we're going to go ahead and exit the loop. Otherwise, we're just going to continually read input from the user. So notice that by detaching, my Sentinel value from the loop conditional and putting it into a separate conditional, I've got this situation where I can still exit my loop when the user inputs something. I've optimized this down to only using a single input statement. And so if I run this and just keep entering numbers, and oops, I forgot to apparently click console, but that's okay, because now you'll see that no matter what I enter, this just keeps going. And then eventually if I hit 999, my program's over and it exits. And actually if we put an output statement down here so we know that we're done, it makes things a little bit easier to see. And I'm actually going to switch all this to console input because it's a little bit easier to deal with. And we'll change this to console as well. And now we can see this work again using the console. So I can continue to enter numbers as many times as I want. And then eventually when I enter 999, we're done. So this can be really helpful. So what I want to do now is I want to set up a variable to keep track of all the numbers that I've entered. And I'm going to call it sum. So I'm going to put this in here first. And I'm going to make that. So up top then, I'm going to create a new variable called sum, and I'm going to set it to 0. So just like I need a variable to count how many times something has occurred, I need a variable in this specific example. I want to accumulate the total number of all the items, or sum up all of the items entered. And so I'm going to use basically use a variable called sum to do this. So think about if you're writing a video game and you wanted to keep track of a user's score. you basically keep accumulating all of the points that they are gaining in that game. So in this specific case, I'm using sum. You could probably call this score in a game or whatever. And so each time through, what I'm going to do is, if they enter all 9s, I'm going to exit the loop. But if they don't, if they enter any other number, I'm going to take the value in sum, and I'm going to add it to what the user entered. So take the value entered by the user, in input, take the value entered by the user, add it to the current running tally in sum, and then save it back over sum. So again, this right to left. What is the user's current score? Add it to what they just entered, and then update the variable with the new sum of those values. And so now if we run this, what we'll get is I'll enter 2, 3, 4, right? So we should end up with a sum of 9. You'll notice that the sum of all the numbers entered is 9. So this idea of using a variable to either keep track of the number of times that a loop executes or using it to add up all the values entered by the user is really helpful.